Alright, hello geometry. Today we're going to do 11.7 pyramids. So thankfully pyramids and prisms are very alike. Sometimes we get confused on which is which. So I want to clear that up first. And then we're going to talk about the equation. But the equation is very, very similar to the equations for prisms. So first let's just draw a prism real quick. I'm going to draw a rectangular prism. So you have your rectangle like this, and then it projected 3D, so it's like coming out of the, closer to the screen here, or closer to the camera here. It comes out, and you have this like box essentially. So this is what's happening here is that your extension, so the corners or the vertexes, we might say, the vertexes, yeah, on the outside of the prism are all going straight up. Like they're just lifting up like this, no issue here. It's just going straight up. And they're just going to make this second rectangle exactly the same as the bottom one down here. They're going to make a second rectangle exactly the same as the bottom right here on the top. That's a prism. That's a prism. When you make the same base on both top and bottom. A pyramid, and I'll draw a rectangle for this. A pyramid, what's happening there is that the top of the corners or your vertexes are not all going to straight up. What they're going to do is all meet up at a point. So all the corners projected, so coming out of the screen or coming out of the whiteboard, all come to one point like that, like a pyramid, like it's getting pinched, right? You're bringing all your fingers to one point. So here, the projection, the 3D projection, they're all coming into one point. And this point right here is also a vertex. We call the corners vertexes sometimes. So this right here is going to be meeting up at a point. Well, this right here just basically remade what the bottom or our base is on top. This right here all joins into one corner. Okay, let me do it with a triangle. So a triangular prism would look like, I should use the light blue as my base. So a triangular prism, it's going to look like this. So here's your base. Let's make it a little bigger. When I say a triangular prism, that means the base is a triangle. If I said a rectangular prism, the base is a rectangle. If I say octagonal prism, the base will be an octagon. So again, you have your base, which is the bottom of your 3D shape, and then a prism would project straight out. So a prism would project straight out, and I'm drawing a little bit more to the side, and maybe I should draw it a little better though. But and the important thing is that this bottom one right here is going to match the top of here. So it's going to be the same on top and bottom. Okay. A pyramid, a triangular pyramid, would be you have your base triangle here, and then all the points match up to one place. And I'm doing it to the left, it doesn't really matter. But all the points match up to one place, like you're pinching the top of it. Like you're pulling out, I don't know, like taffy, I guess, or something like that would like kind of form and congeal like that. So those are the difference of pyramids and prisms, okay? Now, the difference is not only in the shape, but also in the formula. For a prism, our formula was this. The volume for a prism is capital B, so the base of whatever the type of shape it is, times the height. Maybe we should use capital H, but H is the height or that 3D depth. Okay? So H is how much is coming out of the screen. So for example, this prism right here would be volume equals the base in this one is length times width. So the whole volume's length times width times height. The volume here the area of the base, which is a triangle in this case, is 1/2 little capital B and H. So I'm going to go put 1/2 base times height times, and I use a capital H for the 3D height, okay? So sometimes we have to differentiate. Those are two different heights. Sometimes we call it depth. All right, so here, the crazy thing about the equation is basically the same. The only difference, it's volume 1/3 base times height. I'm sorry, capital B, base times height. So look at here, volume is base times height. Volume for a prism is base times height. Volume for a pyramid is 1/3 base times height. So what does that mean? All you have to do is divide your answer by 3. You could also write it like capital BH divided by 3. That's also the same thing. And I want you to notice there's a kind of similarity. Notice here, the length and width could be also written as base times height. And then a triangle is 1/2 base times height. So when it's 2D, so the rectangle becomes a triangle, it cuts in half. When we talk about 3D, the prism, which these sides are rectangles, into a pyramid where these sides are triangles, it becomes a third. So the volume for a prism, for a triangle, or a prism for any shape, is going to be 1/3 base times height. This is the important thing you want to take away. So why don't we just do a couple of examples? All right, so I tried my best to draw one that's well. Definitely just benefits from textbook / computer / if I could do this on a smart board, that would be nice. But here's our shape. It's a hexagon with a it's a hexagonal pyramid. It's a hexagonal pyramid. Not hexagon, I'm sorry, a pentagon pyramid. So, and I should have said this, a regular pentagon pyramid. So what does that mean? Well, our formula for our volume is 1/3 capital B H. It's up to you to decide what our capital B becomes. Remember, this is a regular polygon. So a regular polygon is 1/2 the side length, or the size of the side, the apothem, the number of sides. So let's find B first. Let's find capital B first. So it's 1/2 times the side length. So the side length out of all this, so 10. The side length out of all this is 12. And then since it's regular, you know all the sides are 12. So this is 12. The apothem length. The apothem length is that length on the inside. Sometimes, like again, it's because of my handwriting, the drawing's kind of cruddy, but I think the book is a little bit more clear when it happens. So the apothem here is 10. And the number of sides, so this is a pentagon, so the number of sides is 5. Okay, so we put that in the calculator. 1/2 times 12 times 10 times 5. That's a 6, 30. Looks like 300 units right now. So B is 300. So let's go. Volume equals 1/3 times 300 times that 3D height. I drew it to the side because it would be too hard to draw in the picture, but the H is 15 in this case. So it's 15. Okay. You would type that in the calculator too. Again, you could also do 300 times 15, then divided by 3. But this should be altogether, well, 300 divided by 3 would be 100, and 100 times 15 would be 1,500 or 1,500. And the units, because we're talking about a 3D dimension, so a 3D shape, is unit squared. This does not affect the number. It's just unit squared or inches squared or feet squared. Units, again, I know charge you points off if you forget the units or don't think about the units. But it's important to understand that it is units cubed. Okay, so that's an example of a, let's say I took a pentagon, a regular pentagon. Let's do a more basic example just with a, let's say, triangle. And I can imagine a triangle be confusing because we're using B and H multiple times. Okay, this is a right triangle pyramid. Again, how do we name it? Well, the base is the first part of the name, so it's a right triangle, so it's a right triangle. And then how the extensions meet up. If it's a projection or a picture of another right triangle on the other side of the 3D shape, that's a prism. If they all meet up at one point, they all meet up like a pinch at one point, that's a pyramid, okay? So this name for this shape is a right triangle pyramid. So since I know it's a pyramid, it's going to be volume equals 1/3. Sorry, I feel like I hope none of it has been out of focus. Base times height. So it's up to us, the person who's doing the problem, to figure out the bases. So the volume, or I'm sorry, the base of the shape is a right triangle. So the base of a right triangle, or the solution for a right triangle, is 1/2 base times height, a little lowercase b. Now, notice I don't tell you explicitly. I give you 3 sides. One of these are not useful or used in this question. So let's try to figure it out. Well, remember, the base and height of a triangle always needs to be a right angle. So it has to always have a right angle like this. So the one with the right angle would imply that one is the base and one is the height. Which one's the base and which one's the height? It doesn't matter. They're interchangeable. But the right angle is the key to tell us which one do we use. So capital B, so big base, I guess you could call it, is 1/2 times the little base. I'm going to call it 9. If you called the base 12, that's fine. And the little, I guess the 2D height is 12. If you called the height 9, that's fine. But definitely understand that 15 would not be the one included in this situation. Okay, so you have 9 and 12. So let's do the math. 1/2 times 9 times 12. 1/2 times 12 is 6. 6 times 9 is 54. So right now the capital B is 54. We're not done. We just found the first part. Okay, just as a reminder, our volume's 1/3 base times height. Maybe I'll just write it right here. Volume's 1/3 capital BH. So the volume is 1/3 capital B, which we just figured out is 54. And I always recommend solving the capital B first before you plug it into the volume equation. Solve the capital B first before you plug it into the volume equation. You could technically all do it in one shot. Sometimes that messes up with confusion, especially when you're dealing with something like a triangular base, because we're talking about 2 different base and heights, and a lot of times people get confused with that. So we have 1/3 times 54 times our 3D height. Again, it's hard to draw it, but it would look like it would also have a right angle, kind of look like this. It would try to be in the middle of the shape, kind of like in the middle of the shape, and it would go like that, okay? But this height, this 3D height is 6. So that 3D height is 6. So 1/3 times 54 times 6. So all that volume, 1/3 divided by 6. I'm sorry for the trucks driving by. 1/3 divided by 6 is 2. So 2 times 54 is 108. Units cubed. It could be inches cubed. Again, doesn't really matter. That part right here doesn't matter, but I should tell you it's some unit cube. Okay, so I hope this helped out with the videos. I'm going to have a Zoom today. Probably, I think for either class, whatever is 3rd or 4th period, should be 10:15, okay? All right, have a wonderful day.